Okay, let's give a minute so that the slides show up. Thank you very much, everybody. Prithpal, Khajuria. So I'm very happy to be here and honored to be here with all of you guys. So I'd like to discuss a little bit about the microgrids and how, from Intel perspective or technology perspective, how can we simplify and move things faster? I think there's one misconception I see. Microgrids are not there to provide you cheapest power than a traditional generation. A traditional generation is a large-scale production that will be always cheaper, okay, than we doing a small-scale production in a microgrid. Okay. So if we compare with the cost of building a new power plant, putting transmission, distribution, and then compare with the cost of the microgrid, then we will understand it. But just don't look at that, okay, this microgrid is too expensive. So let's see if you have the slides here. It's moving. Okay. So everybody's familiar with this flow of the traditional grid architecture. From the power plants, power is flowing to industries, homes, and businesses. It has been going like this for 100 years. And no, there is a reverse flow of power. What are the basically trends? What is driving for people to start using the renewables? I give you my personal example. I have my little microgrid at my home. I did a few years back, I did an analysis. If I take the solar battery, will I save some money? The cost was basically, ROI was 10 plus years. It was not worth spending money on it. But 2 years ago, I did the analysis again. What happened? I went to US 20 years ago. I bought 2 cars. And so I was saying, okay, look at it. The electric cars came here now. I am paying a few $100s for the electricity bill. I'm spending at least $300 a month on my, $600 a month on my gas, burning the fuel in my cars. If I was basically, my cars were at the end of the life, so I need to replace. I say, okay, what is the cost of putting a solar plus battery on my house and what I'm going to save? Basically, my energy cost, which I was basically paying to the utility, paying to the gas company for petrol in my cars, putting all together was around $800, $900. Okay, I went and put my little microgrid. All of a sudden, basically, I eliminated all that cost. I pay $0 for my gas bill on petrol in my cars because I have electric cars. I basically have the PV solars produce powering all my house. So that is where the value is if we look at it. So it does not fit at every culture, at every society, because everywhere the cost of energy is different and people consumption is different. But in my case, it worked. I spent basically $20,000 on the system, and with all the tax subsidies and everything, basically my ROI was 1 year. In 1 year, the money I save, I pay for the system, okay? And next 28 years, 29 years, I don't have to do anything. It's going to pay for it. So we got to look all those things, and I think that's what's great. So my question was that if looking at the purpose of the microgrids, people like me, people like businesses, they are going to go deploy the renewables anyway because they want to save money, because they want to reduce their demand charges, because commercial energy is always expensive. So what we see is that what we call a demand and generation imbalance. In US, in certain parts, the feeders whether the industries have put the solar or people have put the solar, there is a more power coming back to the grid than the people taking from the grid during the day. So what is happening for the utility perspective? You have a model you build in projecting that this much demand you're going to have, people are going to consume energy. People are not consuming energy. They are generating the energy. During the day, there is an imbalance, the flow of energy coming back to the grid. Okay? And then from the utility perspective, no, you got a problem. You are paying money to a big generator, a power plant operator to sell that energy, but your customers are not buying energy from you during the day when the sun is shining. They have excess energy they're producing themselves. Okay? And so that is the biggest, utilities have to think about that perspective. If you are generating the energy and nobody buying it, this means you are losing money, but you don't have a visibility into it. E.ON in Germany suffered huge losses because of that. Because in a lot of the countries, when the net metering is happening, the energy is coming back to the grid, they have to pay to the operator, to the user. So if I put energy back to my grid, I get paid for it. So that is what the challenge is happening, is the demand and generation imbalance. What it leads to, if we don't think about it, it leads to the dynamic overloading of the grid. When the sun is shining, or wind is blowing, a lot of energy coming back to the grid, and stresses the grid, and when that disappears next minute, the load shifts back to the grid, and grid has to step up, okay? Then you have the seesaw continuously going, and which is basically creating a dynamic overloading of the grid, and creates your instabilities in the grid, your power factor, your voltage, all these things will swing across. Your equipment will get stressed, and is going to fail faster. So this all gets into the need of what we call it a microgrid. We look from this another angle of looking at it. How you're going to basically work with this, whether the homeowners, whether the large or medium scale industrial complexes, how do you work with them to basically have a very seamless operation and use them as a valuable resource, okay, where it can take off the load from the grid and you don't have to burn that much fossil fuels to provide the power. So it is a balance, it acts as a balancing act in the grid, basically. So what it leads to, that we need to increase the awareness into the power grid network. We need to modernize our infrastructure, because now the secondary substations, if we look at the Indian architecture, secondary substation, that is where all the customers are connected, depending upon the size. Now we need to see at the secondary substation level, we need to know what is happening, what is the profile of this substation, how renewables are acting on the other side of it, and we increase that visibility, and based with the distributed intelligence and the substations, we can apply the autonomous controls. We can control the flow of the energy, okay, and switch back and forth, as we say, grid connected or islanded microgrids, how that operations are working. We need to manage those seamlessly. So going to the next level, rooftop solar is another problem. We have not done the smart metering, but when we did smart metering in US, the biggest value for doing smart metering was cutting the spinning reserve. In US, utilities have to have a 15% spinning reserve, okay? And by collecting the data from the smart meters every 1 hour, every 4 hours, we can optimize our forecast. And then we can reduce the spinning reserve. If we can take it from 15% to 10% to 7%, we'll save billions of dollars every year and reduce the greenhouse gases also. That was the value proposition for doing the smart metering, but nobody talks about that. Okay, everybody's running in a different direction. How can I have it cheapest? We need to connect it, what is the real value, and look from that, and I think that's where the technology brings the value. But where we are going the next step now with the smart metering technology, with compute technology reaching to the level, and also we have the analytic capabilities. The future power meters will be containing what we call load desegregation algorithms. They will be built inside the smart meter, And from there, it can identify when your electric car is charging, when your solar is producing, when your storage is acting, all the load. And we can take that load information and feed directly to a secondary substation. And from secondary substation, we can profile the behavior of that feeder, okay? And then we can optimize it better and balance it. And yeah, of course, you can do all the traditional stuff, the billing and everything. But we need to think in this way, holistically, that how to solve these problems, okay? And bring the value to the customers. And from utility perspective, microgrids are not your adversaries. They are your friends. When a big industrial complex is producing power during the week, but weekend when that is shut down, you can have that power coming back to the grid, okay? And you can use that power for some other purposes. And it is a mutual benefit. We need to look into it. So this is a kind of a microgrid, little bit architecture, how you can build the next generation, what we call it from a data center for edge applications or a micro data center. You can have all this basically infrastructure running at the edge, doing all the activities from autonomous control to analytics and basically predictive maintenance. Everything can be done basically right there at the edge. There is no need to run the data back to a big cloud, need a lot of communication infrastructure. Everything can be done at the edge. And that's where the Intel is putting a lot of energy in the technologies, working with our partners, GE. So then this is the next step, is basically how the secondary substation are going to work. Look at this basically use cases from the secondary substation perspective. We can do all these things from there, from the DER management, DER, distributed energy resource management, all the way to domain response, EV management, power storage management. Everything can be done from there and seamlessly, and you're basically the future distribution control center will become a system of systems, because all the actions are being taken by the secondary substation, and you're getting all the information what is happening. So we got to look into that perspective also in this modernization approach, have microgrids and the utilities connected in this seamless behavior and working very closely with each other. So it's another basically how this hardware can be, there's a multiple capabilities, hardware can be available from a low cost and all the way to high end, depending upon where the application is. And the beauty is applications can be virtualized. You have a need for 1 or 2 applications today. As your need grows, there is no need to go, okay, no, I build a small hardware, it cannot provide me the future needs. You can build a hardware with a certain headroom in it, keeping that these systems will last 15 years in the marketplace. Your needs will evolve over that 15 years. Those things can be built. And I think that's where it comes into what I see, that everybody thinks about, oh, what is the cost of the system? But think about what is the cost of not doing it, okay? One of the largest utility in the world, I was talking, in their secondary substation, they have 5 different systems. One was their concentrator to read their smart meters. They have a low voltage bus bar monitoring system. They have a medium voltage monitoring system and couple of more things. 5 systems, 1 router, 1 power line carrier gateway. So they say that they have 5 systems and they put into these different boxes and says, okay, no, I have a DERs coming. What can I do? I got electric vehicles are coming. There is no way you can keep these small fixed feature boxes keep going. We need to think in future that we can build a system which will last for 15 years. Yes, it might cost a little bit more, but think about going to a substation every few years and basically ripping everything and putting a new thing there, how much that costs. Okay. I think we need to do that analysis also together, and that's where Intel provides that free consulting services Okay, and that's what I do, working along with the utilities worldwide, looking into the problems they are facing in modernizing the grid and building the reference architectures which can be implemented to solve those problems. So how this whole works, you have a whole microgrids. They all connected with a management platform. You can do it, manage everything remotely. In the future idea is that when this kind of infrastructure comes, there will be a marketplace for applications. As utilities or microgrid operators, you can go to that marketplace, download your application, which are already tested, verified, and move forward. Yes, sir. So this basically the standard questions about security. All these things have been taken care into these platforms. There's no silver bullet. There's a multiple layers of securities, and that all and data segregation. Everything has been built into systems. In the networking, basically, if you want to divide the data into various segments, they need to go into various systems. All can be taken care from these basically systems at the edge. Thank you very much.